Well. Oh man, it's going to be very beautiful, friends. It's been ages since we get together. Tonight we're going to do something wonderful, as usual. Now we're going to talk about the expansion of fractional exponent. Okay, this is volume 10 that we're going to tackle. Now our question is going to be the same fundamentals that we've been working at, the same procedure, the same ways, the same approach, as far as you stick to the guns of the methodology that we've been going through it. So this is going to be our question for tonight. Let's have a look at the question we're going to deal with. This is what we have at the moment. And so the beautiful thing is the same old story. It's a simplified expression. The fifth root of z raised to the power 9 multiplying the cube root of z squared, all divided by the fourth root of z raised to the power 5. Friends, as you can see, it's so beautiful because everything we see over here is nothing new. It's something we do. All this while, if you look at it very carefully, you see that everything is involved with z. You see, here we have z raised to the power 9, and also here we have z raised to the power 2. You see, and the bottom one is z raised to the power 5. Okay, so what do? All what we do is to convert it to the way it's supposed to be. So how do we do that? Let's see. Now, so we have z raised to the power 9. Yeah, there's the fifth root of z raised to the power 9. Okay, so let's see. We have that. So let's look at it. So we have fifth root of z raised to the power 9 multiplying a cube root of z raised to the power 2. It's all divided by fourth root of z raised to the power 5. Friends, how do we make it very simple for ourselves? Let's look at it from this angle. So, if you look at it, this can be written as z raised to the power 9 all into bracket 1 over 5 multiplying z raised to the power 2 all raised to the power 1 over 3. You see, then it's dividing, as you see, we can see it's dividing. So what do? Is this all divided by z raised to the power 5 all raised to the power 1 over 4. Friends, you see 1 divided by 4. So you see, we have been able to make it easier for ourselves so that the subsequent calculation is supposed to be easy for us. We all know that the meaning of what we see over here is that the 1/5 over here is multiplying the 9 over here, and the 1/3 over here is multiplying the 2. Okay, likewise, 1/4 over here is also multiplying that. So if that is the case, then our equation is going to change. Let's see how big it changes for us. So you know that when we multiply this and that, we are going to get z raised to the power 9 over 5 multiplying z raised to the power 2 over 3. You see, divided by the bottom one, which is z raised to the power 5 over 4. You see, we are gradually breaking the back of the camel. It's becoming easier. Now, friends, I always says that if we apply what we know already, in a nice way. It makes life easier. If you look at the top one here, that's, I will highlight it with that. Let's see. You see, if I pick this one and I look at the top one only, I see the top one here, you see, shows that there's a multiplication going on. Yeah, between the two. So what does it come into mind? Well, all what we know is our fundamentals that we've learned over the period that we've been together. Because we know by the property of indices, you see, by property of indices, that if I have A multiplying y, a raised to the power y, then this can be written as a raised to the power x plus y. You see, so if you look at this, friends, if you look at this very carefully, you will see that we can apply the same to what we see over here. Look at that. For the top here, you see z raised to the power 9 over 5, and z raised to the power 2 over 3. It's multiplying each other. So when we apply this rule, okay, to what we know, then we are almost true to the solution, because we know the top one is multiplying each other. So because of that, now we can confidently say that the top one, which is z raised to the power 9 over 5 plus 2 over 3, because they are multiplying each other. Then we bring the bottom one, which is z raised to the power 5 over 4. Friends, it's becoming easier. Now, let's check something. It's so easy, but where sometimes, most often than not, students found themselves fumble is where we see z raised to the power 9 over 5 plus 2 raised to the power 3. It's just nothing but what? Fraction. Let's see how we can solve this. You see, so that it will be so easy for ourselves. Look at that. This top one here is what? The issue where students find themselves fumbling, because they've forgotten that earlier in their classes they learned something that is called fraction. Friends, this is fraction here. Yeah, it's no more difficult. It is fraction. So how do you, simplify 9 over 5 by 2 over 3? Because they're adding. So let's go and do this simple fraction and see the best way to be easier for us. So let's forget about a z in the meantime. So now here we say 9 over 5 plus 2 over 3. Friends, it can be easier more than this. You see, you'll be able to break the back of the comma. And now the simplest thing is we must be able to solve this fraction we see over here. And we know for sure we have to find our lowest common multiple, the LCM. Okay, the lowest common multiple. And how do we find that? We have to multiply 5. Yeah, the 5 we see over here. Let me highlight it. This, we have to multiply this. We have to multiply this by that. So it's going to be 5 times 3, which is what? 15. As we learned earlier, yeah, when we were studying how to do fractions, addition or fraction. So now let's see, how do we do that? Okay, so having that knowledge at the back of our mind, we know our denominator, the LCM, is now 15. So we say this divided by 15. Okay, friends, this is simple. Now we know that 5 goes into 15 3 times. We'll write it here. Okay, then also we know for sure, that free, yeah, free will go into 15 three times. So what do we do? Now it's so easy. So we say 9. You see, so we take this one and multiply by 9. So 5 going here, give us 3. So we say 9 multiplying. Okay, so you can put bracket. And I know it's multiplying 3. Now I'm going to close my bracket because I've dealt with that one already. And I have my addition sign here. So I say plus. Friends, you know there's 2 here. And the 3 goes into 15 5 times. So we say 2 multiplying the 3 over here. Okay, so this one goes here 5 times, sorry. Okay, so 5 times, that's we know. So 5, multiplying by that. So 3 goes to 5 times. Let me write it properly so we can see it very well. Okay, doing it good. 5 times. 5 times. So, as you can see, so we put our 5 here. Then we close the bracket. Okay, so this is how we do fraction. So we know 5 goes into 15 3 times, and then 3 goes to 15 5 times. So when we simplify this, what do we get? We are going to get 3 times now, which is 27, plus 2 times 5, which is 10, all over 15, and this will be 37 over 15. Friends, you see, we came out of the property of indices, and our attention was totally on fraction. Now let's see something. So we are able to compute our fraction nicely and in a logical way. You see, so let's see. So all this one we've done so far, all these ones we've done so far, this one, you see, it's all with reference to fraction. Okay, and our answer we got is this, 37 over 15. Okay, so we'll go back and substitute it back into our equation. Now let's see. You see, so now here we are able to sort it out. So instead of this whole expression here, you see, we are able to compute this. You see, so our concentration is now supposed to be with the continuation. So we'll substitute it back. Okay, let's go back to our blue color. Okay, so let's see. Okay, so now we have z raised the power. You see, so we have z raised the power 37 over 15 divided what we have there, which is z over 5 over 4. You see, friends, z over 5 over 4. So this z over 5 over 4. You see, we have not finished it. We haven't finished it because why? Now it's division. You see, this is division. This is division of indices. This is division of indices. And what does it say? Division of indices. It says if I have a raised to the power x dividing a raised to the power y, which can also be written as a raised to the power x dividing a raised to the power y, then it can be written as a raised to the power x minus y. You see? So that is how it is. Anytime we have division of indices, all what we do is to apply what I've written here. Okay, let us highlight it. Okay, Now, so this is the division of indices. You see, that's what we see over here. Then let us highlight it. So this is the property of division of indices. Okay, now let's see how we can apply this to the last bit of the question that we see here. Now let's go and sort it out. So 7 raised to the power 37, the z raised to the power 37 over 15, and the z raised to the power 5 over 4 is our concern. So let's sort it out. Okay, so we know now z raised to the power, let's stick to our blue color. Okay, so now we are here. Okay, now z raised to the power 37 over 15. Okay, dividing z raised to the power 5 over 4, which we can write that z raised to the power 37 over 15, yeah, dividing z raised to the power 5 over 4. Knowing this rule, as we applying this, meaning we are going to subtract the exponent for us to be able to apply the principle of indices to this very particular stance that we are. So now let's see. So this is going to be z raised to the power 37 over 15 divided by z raised to the power 5 over 4. It means it's going to be written as z raised to the power 37 over 15 minus 5 over 4. Friends, what are we seeing now? Now we've gone to the game of fraction again. So if we are solid with our way of solving fraction, then we are far away from saying that it's difficult or something like that. The student always find themselves saying, it's easy. You just have to apply what you have learned earlier. Okay? Because we don't learn backward, but we learn forward. Because math is application in our life. You know, life is changing. Everything's going to change in the near future. You know, now we're talking about cryptocurrency and everything. It's all mathematics. You see, probability and all those ones. If you stick to it and learn it very well, then you're going to be a very financial guru. We can't do away with maths if you want to get into deep finance and, you know, further calculation. People learn how to become good in math. They practice all the time. Okay, so math is always everywhere we go. We see math because it's the application of everything we do in life. Yeah, friends. So let's see how we can go about to solve this fraction. So easy that we'll be smiling at the end of the day. You see, people who are doing actuarial science is all mathematics. And if you are good in maths, that will take extra mile. And this all boils down to the basics of math. So now let's go about it. So now we can see that our equation right now is fraction. Let us highlight our fraction. You see, so now when I look at that, you see, this is the fraction we're talking about, friends. You see, this is the fraction that we have to solve. You see, this is a fraction, 37, yeah, over 15, and minus 5 over 4. So let's go about it and let's break it down. Okay, so now we have our equation or expression term. Okay, so we have 37 over 15 minus 5 over 4. Okay, so what do? The same way we have to find our LCM. Okay, LCM, the lowest common multiple, will be to multiply 15 and 4. Okay, so that will be 15 multiplied by 4. Okay, so 15 multiplied by 4, and that gives us 60. Friends, what do you do once again? So this, now we have our LCM as we did earlier. So we say this all, yeah, this all is divisible by 60. 60, to go through the 60. So what do? We have to look at it once again. See that 15 goes to 60 how many times? Okay, and also we have to look at it and see how many times will 4 go into 60. Okay, so how do we do that? So meaning we are going to divide this 15 here by 60. Okay, so this divided by 15 which gives you 4. So it multiplies this place by 4. Friends, so this is 4 times. Okay, the 4 goes to 60 how many times? You see, so this we say 60 divided by 4. And that gives us 15. You see? So now we know that our expression has become so easier for us to solve. Now 15 goes here 4 times. So this is going to be into bracket. Okay. This will be 37 multiplying the 4. Okay, then we say addition side, we'll bring it here, plus, into bracket, what do we have here? We have 5. Multiplying, what are we going to multiply? We are going to multiply by 15. You see, this, then we close our bracket. You see, we are almost there. So what do? Now it's simple simplification. Friends, this is minus, don't forget. Okay, so this is minus because we are subtracting. Good. So what do? So 37 by 4. Let's see how we go about it. So 37 times 4 will give us 148. So 148, let's write it down, 148 minus 15 times 5. 15 times 5, that gives us 75. So all divided by 60. So what do? We subtract. So minus 148, okay, will give us what? 73. So 73 all over 60 is the fractional value. So now we know that question has been solved. But bear in mind that before we go to this place, we were here trying to compute the fraction of 37 divided by 15 minus 5 over 4. Okay, so now it means if we have z, which is 37 over 15 minus 5 over 4, our answer is z raised to the power 73 over 60. So that's the final answer. Yes? So that is what we get eventually. So our answer now is z raised to the power 73 over 60. So this is the final answer. Well, somebody was asking me a question, can you divide 73 by 60? I said, definitely, you can do that. So if you have 73, okay, divided by 60, friends, what do you get? Yeah, in decimal, we're going to get 1.2. So this can also be written as z raised to the power 1.2 as the final answer. Yeah, so it's not difficult at all. Yeah, so let's go and quickly scan through and we'll say bye for the day. So now look at it. Our first instant was a question posed. It's a simplified expression. And what do we do? When we saw that, we know that it's so easy, friends. Why is it so? It's so easy because we have a fifth root here, okay, and this is what cube root here, and here this is what 1/4 root. So 7 raised to the power 9, and as a z raised to the power 9, a z raised to the power 2, and a z raised to the power 5. So z raised to the power 9, this can be written as z raised to the power 9 raised to the power 1/5, and as it goes on. And after that, we realize that, after expansion, this is what we achieved. Okay, now we have to compute it. And what happened to our computation? Okay, now let's look at it. Our computation, so we realize that this and that, okay, this and that is order of the day. If I look at this and that, you see, this and that, I have to apply this to the rule, because I know that z, okay, multiply z to the power 9/5, multiplying z to the power 2/3. It's just fraction I'm seeing over here, but it's nothing that, since we have z and z being the same, meaning we are applying the property of indices. The first one, I say the product of the exponent a raised to the power exponent x times a raised to the power exponent y is given as a summation of the whole thing. So by so doing, meaning if we apply to this, that we are going to have 9 raised to the power 5 plus 2/3, and this becomes a fraction. That's what we highlighted with green. Okay, that's why we highlighted this with green. So now our concentration boiled down to simplification of the fraction. Now we got to this point where we decided to apply the rule. As you all can see, it's basic. 5 goes, this 5 here goes to 15 3 times. Okay, so we put here 3, and then 3 goes into 15 here 5 times, you see. So then we'll put it and did our simplification, and we got 27 plus 10, which was 37/15. Now, you see, our equation changed because we are able to deal with the top one. Now, if we look at it too, we see that they are dividing. So we applied another property of indices, which is a division property. So that's a raised to the power dividing a raised to the power y, a raised to the power x dividing a raised to the power y. And that's what we get as a property. And we did the same procedure. And we realized that over here, because they are subtracting, the fraction changes. So we go down here, you see, and we apply the same procedure we saw earlier. And our answer got to z raised to the power 73/60. Well, in the process, somebody asked me a question, that why is it that it's 73/60? I said, well, you can stop dividing. Yeah? So the answer is eventually z raised to the power 1.2. Well, friends, that's why we say goodbye. Please go there and subscribe to the channel and introduce the channel to your friends, so that all our friends will be on the same platform. Well, I'll say goodbye to you and have a lovely day.